Friends, again this is Dr. Paul here from Genesis Technologies, Mumbai, India. In my first lecture, I have covered the qualities and characteristics of entrepreneurship. So first of all, if you are doing entrepreneurship on the basis of technologies, and you need to develop those technologies first, and those technologies should be convincing to the scientific community before taking it to market, whatever you call it, the product promotions. We have developed many technologies which is required for climate change studies. These are all simulation models. In this presentation, I am going to cover few technologies which are very much important for mitigation studies. So my presentation topic is climate change studies in India with various approaches, simulation and modeling. The first objective is, when you have a technologies, you need to sort out the number of technologies what you want to promote it. Considering the area of application and who will be your target customer, everything has to be decided and planned accordingly. You have to have scientific literature, technical documents, write-up, everything should be ready, and also the system prototype also to be ready. So currently we are going to handle few technologies like number one, temperature gradient tunnel, open top chamber, free air CO2 enrichment technology, free air ozone enrichment technology, free air temperature enrichment technology, elongated tunnel, elevated bioreactor, and few other systems like aerophonic system, hydrophonic system, walk-in plant growth chamber, controlled greenhouse. There are various things which are required for different agricultural research purposes. Now the question is how you want to do that. In order to achieve, you need to have first the system designing which is required for the specific application, and then procurement of components, development of monitoring and control system, what is the logic control, data storage, data management, system operation and system development, and system support. That is what it is more important for operating those systems in long run. The first technology what I am going to cover is the open top chamber OTC technologies. You can see there are polycarbonate structure over here, and top portion is open. Open top chamber is a kind of a structure, either it is of 3 meter, 4 meter, 5 meter dia, and height up to, it can go up to 10, 12, 15, 20 feet based on the kind of crops you want to grow inside the chamber. The objective of those chamber, you try to simulate a kind of environment inside the chamber. Either it can be temperature, ozone, CO2, or any other gases what you feel that is impacting our environment. You want to have a elevated atmosphere created inside the chamber. You want to grow and study the impact of those plants, how they are responding in various temperature, ozone, CO2, and whatever condition you want to set up. The main objective of those projects is to develop suitable varieties which are capable to give best productivity and you want to develop the germplasm for the future need to mitigate the climatic conditions, because of the global warming, whatever things are happening, that we are expecting global temperature is going to be rising, your CO2 level also going to be increased. So there are various factors like ozone depletion, everything is coming into the picture. But now the question is how to sustain and survive in these adverse conditions until or unless you are adapting those kind of crops into that conditions to adapt such kind of climatic conditions. When it is required, probably those germplasm can be used for agricultural crop productivity purposes to counter the food scarcity. This is what the main objective of those kind of projects. So now coming back, as I have told you, CO2 elevated OTC technology is basically a facility. It is OTC is capable of providing a means by which the environment around growing plants may be modified to realistically stimulate future concentration of atmospheric CO2. What it means that again each chamber has to be stimulated in a particular conditions for a long time, and those conditions to be exposed to the plants for their growth, and you have a monitoring control system, measurement system, so that you can observe whatever biochemical physiological changes are happening. This is a typical schematic of a OTC project. Here you can see 1, 2, 3, 4, 5, 6 OTC is been connected to CO2 cylinders. CO2 supply is given to each chamber, and each chamber is having the sensing option for temperature, CO2, ozone, and again it is all data logged through a data logging system. Then it is connected to a computer, and PLC is there for controlling each parameters. So it is basically it can be wired or wireless system. So this is a fully automatic system where when you can have your parameters set and you want to run the system, like out of 6 chambers here you can have one ambient, one only CO2. Maybe your normal CO2 level is 380 ppm, you can have 500 or 600 ppm, another is 700 ppm. One is only temperature, two different temperature variant you key, ambient plus 2 degree, ambient plus 3 or 4 degree, and another system you can have temperature plus CO2. So combined effect both temperature and CO2 you can check it. Like that you can have system designing, like, and you can run experiment throughout the crop season. So this is more or less the schematic. Here you have the control room. From control room, from the computer, you can operate the system. Now we have developed many open top chambers in India and abroad. So this is basically again a schematic, what is showing the IR heating system, how the logic control and everything it is been developed for data logging and communication purpose. This is the schematic that is been provided here. This is a typical system setup for experiment. You have the OTC here, you have backup diesel generator. This is we have developed for College of Agriculture, Gwalior. So this project is a very big project. Here their main objective is to work on various crops and to be exposed with different CO2 level, ozone level and temperature, and you have the complete monitoring and control facilities for ozone, CO2 and temperature for each OTC that has been provided to them. And this is a typical data logging system for this complete project. This data logging you can have every many 2 minutes, 3 minutes or 4 minutes interval. You can set accordingly how you want to have the data logging and controlling option. This system comes with a weather station and with rain gauge, sensor, with wind speed, wind direction, solar radiation and power, temperature, humidity, all those monitoring system that has been provided apart from those OTCs. The system is connected to a 20,000 liter CO2 tank with a vaporizer and everything that has been connected to the system for supply of CO2 for those OTCs. Those are basically the sensor module, temperature sensor with radiation seal, is a humidity sensor and CO2 monitor and ozone monitoring system over here. So this is the infrared heater, IR heater. It's a short wavelength infrared heater mounted at the top to maintain the temperature, because when you are doing the elevation temperature studies, you want to maintain temperature ambient plus 1 or 2 degree. You basically want to put the heating system, and we are using infrared heating system because it is increasing the air temperature very fast, and it doesn't create the gradient atmosphere, and the uniformity also is maintained. And those structure, OTC structure, is made of polycarbonate sheets. It's one side UV protected one, and this polycarbonate sheets of 6 mm with 80-85% light intensity. It's very clear, and on inside you have complete drip irrigation facilities has been provided along with the system. So apart from this thing, we have also provided soil temperature probes also is there, soil moisture probes are there in each OTC. Now this is one project we did it for Kharagpur IIT, and this is long back we did this project, and still they are working for various crops. This we have done for Otc Bhubaneswar. So this project is basically they are working on developing various rice varieties under CO2 elevated conditions. So both temperature and CO2, they are all together 8 or 10 OTC you have provided, and some are for the ambient application, some are for CO2, some are plus CO2 plus temperature applications. So this is Otc Bhubaneswar. This project we have done it for ICRISAT Hyderabad. Now they are working on various legumes, and this is an international research institute, and we did this project for them, and we have also done few more OTC, TGT, CO2 gradient tunnel phase system also for them. I'm going to explain my next slides what we have done for ICRISAT. This we have done it for Bharatiya University. These are OTCs are mostly they want to use eucalyptus plants and other plants. They want to expose with different CO2 level concentration and to check the growth and productivity of those plants. This is the Bharati Darshan University project we did around 8 years back. We did it for CPRI, that is Central Potato Research Institute, Jalandhar. This is ICR Research Institute. There are altogether 6 OTC you have developed. They are working on tuber crops like potato. They want to grow potato inside those chamber, and also created high CO2, high temperature level conditions, and those systems can be used for ambient CO2, CO2 plus temperature with different CO2 level from 400 to 1000 ppm level. You can set and conduct your experiment. This we have done it for FRI, Forest Research Institute, Dehradun. They are working on teak and other tree species they are working. This is a very around 5 or 6 meter length, and those are used both for temperature, humidity control and monitoring. It's been provided for each OTC, and this project we have done 6-7 years back for Dehradun. This OTC we have done it for TNU, Tamil Nadu Agriculture University, for the crop physiology department. They are working on various seasonal crops like rice and many other vegetables and crops. They are working on those projects. Those OTCs are developed around 4 years back. This is again, we did this project for same Tamil Nadu Agriculture University. They are working on rice, and this OTC is circular in size. You can see, and this OTCs are basically they are using for temperature and CO2 elevation studies, and this we have done it for their microbiology bioenergy divisions. So if you see the list of projects we did, it's quite amazing number. There are so many institutes starting from IRI, OUT, ICR, IIT, Assam Agriculture University, ICRISAT, Bharatiya Darshan University, CPRS, FRI, TNU, Hyderabad University, Central University Gujarat. There are many places. After that we have done many projects. Those lists are not included over here. So close to 150 to 170 OTC we have developed, and the interesting part, all the projects wherever we have installed, those are in working conditions, and we are supporting them for last many years. Now we have talked about this technology OTC. This is our indigenously developed technology, and it is our own logic control. We have developed it, and this is a proven technology. So far this system, as I have told you, it's in operation almost 30-35 institutes. So now I'm taking it to the second level of a technology, because open top chamber is a kind of, the top portion is closed. It is not completely, experiment is not done completely in open atmosphere. Now scientists, they are trying to do a lot of experiment in open atmosphere by enriching CO2 level. So free air CO2 enrichment technology, it's a technology basically in open atmosphere. You try to enrich CO2 level. All you know, the CO2 level in normal atmosphere is 380 ppm. Now you want to have a particular area where CO2 to be exposed maybe for 550 ppm, 650 ppm, maybe 750 ppm, based on the assessment and analysis how they want to do it. Like, the prediction analysis, the scientists try to do it that, okay, maybe 380 ppm adding up to 100 ppm as per the global warming chart. They try to prepare the level of CO2 to be maintained for their experiment purpose. Now the question is, how do you enrich CO2 to 650 ppm inside the chamber? Because CO2, when you are working on CO2, it is very difficult to maintain a particular area in an open space of 650 ppm. As you know, CO2 is lighter than air. It evaporates or dissolves very fast. when you are exposing. Now the question is, you are releasing CO2 through a small pipes. Now your CO2 release should be so precise, number one, so that your entire atmosphere can be exposed to CO2 and it is going to maintain that particular CO2 level. So we use hexagonal or octagonal rings. I will explain to you. As I have told you, the phase system is capable of providing means by which the environment around growing plants may be modified to realistically stimulate future concentration of atmospheric CO2. Now, coming back, to execute this project, to design this project, you need to have a lot of things like CO2 tank, cylinder, vaporizer, high volume blower, octagonal ring, pipe distribution, vent pipe, CO2 regulation system, sensor, measure to wind speed, wind direction. There are many things, analyzer, CO2 analyzer, that is required for developing this system. Now the question is here, there are few things I want to explain here. I have told you, you have hexagonal ring or octagonal ring. Those are basically pipe, either it is PVC pipe or SS pipe or GI pipe. You make micro holes over here. Here from the control room you try to release CO2 and try to purge from here, and each arm is going to release CO2 and it will come at the center. Now the question is how to control and monitor. For controlling and monitor, what we are doing it, we have kept the anemometers over here for monitoring wind speed and wind direction. You have the temperature sensor, you have humidity sensor, you have CO2 monitoring system, either it is CO2 monitor or CO2 analyzer can be there. Now you are developing the control and automation such a way, taking all those factors in mind, because wind speed, wind direction also is one of the parameter which is playing very important role